I made another version right now. Here it is, how it's looking. And originally I put it here, this thing, it was here, but then I realized I need a little bit more space, so I took it out and re-melted here, only the margins, as you can see, and this pad or element, it was here, but then quickly after, usually this is how it's happening, after you finalize, you put everything, then when I did this, when I bent the paper, everything was bending and it was getting closer and it wasn't staying fixed. But right now there is not such problem. This was bendable even in the moment I was touching the paper, but this is not bendable in the moment I'm touching the cardboard. I have to really put some pressure to actually press it a bit more harder, not by touching, by simply touching. So if I'm pressing more harder, it will get out of position. There are two elements here, very important elements. By the way, if to someone that doesn't understand what I'm doing here, this is a leg that I want to spot weld it to that pad, very, very tiny pad. Let me actually point it with my trusty knife here. So that very small pad there, that is the positive pad, and it should not touch this copper. It should be a distance, and it is a tiny bit of distance. I'm not sure if you can actually see, but it is. So this leg is touching that pad, and through that pad to this copper wire that is coming out, pretty much. That is the most important and hard to do thing. And I forget what I wanted to say earlier. Shit. So this is what I want to do here. I want to spot weld this leg. So there are two important, like I wanted to say, there are two important aspects of this problem to resolve. First of all is to keep it in the same position, in the same angle all the time. But not only the angle and position is important, it's also important the pressure. So this leg, I bend it like a spring right now. It's actually pressing a little bit on the pad. There is not only floating, like barely touching it, and we don't know what is going on between the leg surface and the pad surface that is there. So this leg is actually, if this is the leg, I took it from here and bend it like that and force it to stay a little bit springed, you know. And when one is on the pad is actually a little bit in force, a little bit in spring mode. Pretty much, these are the two main problems: position and pressing, and you know, a little bit of force on the leg. So that's what I did there. I should put a little bit of paper as a separator between these two pads, but by the eye, I'm not sure in the camera if it. Yeah, I believe I can zoom in actually. Yeah. From the top here, yeah, you can see it is a little bit of gap between them. Let's see. You see, this is the gap, very, very tiny, but I can see it with my naked eye. You see, there it is, and you can see it is a little bit springy. You see how it's coming back to position if I'm doing that. I know it's not very beautiful. It's very ugly, very, very ugly what I did there here, but it doesn't matter. I actually stay and think 3 days to get on this idea to actually solder with a large blob of soldering to this copper wire here. To actually, this was the idea, to solder this leg, one end there, to actually position it, and also have the spring problem resolved in the same time. So I shot two rabbits with one shot, pretty much. The way I did it before, it was moving randomly the end of the leg, and it was very small point indeed. That was my intention, to use the very end tip of the leg, which is very small. This is a bit more larger, but well, it should be good enough, I suppose. Probably in the future. I know it's a crazy project. I am not sure if I will manage to actually spot weld it. A very good friend of mine from UK, not from America, but from United Kingdom, and not from Romania, unfortunately. We have some very interesting people here with very interesting knowledge in Romania, but they don't like stuff like this, probably. The stuff that I'm doing, at least. So my friend from UK, from England, from the country of kings and queens, I suppose, he remembered, he knows better what I have. He remembered that I have Variac, and that red device that I'm having there, it is a variable transformer, pretty much. And you plug it in, you plug in the device in test, this transformer in my case, I have to plug it in. That is already connected to 240 volts, somewhere there, probably that is the wire. And when I'm opening, I can variate the alternative voltage, is feeding directly alternative voltage to this transformer, 1000 volt ampere, and it's going up to 330 volts. The maximum that is going is actually having written, you see, is written, but I don't take it out from there because now. And actually I made the calculation here. If it's having 330 volts, and actually I turn it to the maximum, and I read it here on the display, it's saying 330, so it's getting up the voltage a little bit, and at its maximum is 1000 volt ampere divided by, this is like volt amperes is exactly like wattage, and divided by volts equal 3 amperes. That's a very, very good idea. My friend from UK again, he had the idea to use a Variac, which I have, And I was staring, I was looking at my variac, but it didn't cross my mind, me personally, to actually try it. But my friend, that's why it's good to have friends everywhere in the world. Doesn't matter where in the world, if it's in UK, if it's in America, whatever country it is, doesn't matter. It's good to have good friends, and most importantly, knowledgeable friends, not stupid friends. And that's the case of my friend. He's very knowledgeable, and it's quite an old dude, and we are on the same line most of the time. And he does not inspire me to be very sincere and to be correct towards him. He doesn't tell me to do all these things. These are my ideas. He is only supervising me and giving me ideas how to solve the problems. But these are not his ideas. These are absolutely my ideas and what I want to try, pretty much. And he is only like a mentor, pretty much. And he is very knowledgeable, and I really respect his knowledge that he's having. So yes, pretty much this is it about this thing. Most probably I will use the variac and variate the power that will perform the spot welding in the end, hopefully without burning anything, without destroying anything important, like my variac there. If that will be the solution, the real solution, it will be awesome. But I still have to solve this problem here, how to hold this little fucker leg on position and on pressure in the same time. So that's interesting, and we will see how it will be. By the way, this wire will be soldered there, and it will have one wire and another wire there, pretty much. And yeah, that's it for now. I hope you like it. Leave a like, motherfucker. And yeah, see you later. All right, hello. I guess everything in life is a lesson, and there are a couple of points I want to add. I managed to put a wire, to solder a wire from this copper element here with this very big blob of solder to there, but let me put this aside because I use something else there. I use solder. I actually soldered this pin here. It's not spot welded, and I couldn't find a solution to spot weld this extremely tiny pad that I have there. It's I don't have the knowledge. I don't have the devices that could help me achieve that very thin spot welding that is required on that pad. And I'm talking about the positive pad there, the tiniest, not the largest, which is the negative. But like I said, after I put the wire here, there is a I believe I managed to spot weld it. It was catching a little bit. If I was dragging the wire, it was lifting the entire blade chip that is there. So it was a little bit spot weld. How good it was, I put it at 100 volts alternative, using my variac there. 120 I tried as well. They give me kind of the same result. The LED is was still working. I did test it, and it was getting me an immediate result with my 5 volts that I'm my tester here. But it was a physics problem. Do you know the lever? When I was moving it around like this, it practically break from the spot weld on the other side there. And until I managed to desolder from this side here, moving it around, most probably it was the moving, it break from the spot welding because it's incredible tiny. That pad is very tiny, and the spot welding is very small and fragile and everything. And it's almost an impossibility. And this actually, where are you? I believe either that. No, this was the wire. This is a leg from a component actually, and this is what I spot welded. I believe this was the end. It's a bit blackened. You can see it's a tiny bit blackened. That's where it's spot weld, and it's a bit thick. I know you will laugh. How, this is thick? Yeah, it's very thick. It's extra mega thick. Compared with this pad, is almost the. Let me actually draw it because even if I'm showing you, it's so tiny everything. So so if this is the square pad, the thickness of the wire is like this thick, and here very close to the pad I have a copper wire here. Copper. It's this copper wire here, and that is the square pad, and this is the thickness of this wire or that wire is the same. It's very thick, and I have very small room here between the two, very small, and then the rest of the pad is longer negative. So this is the positive here. So one problem is positioning this wire. Second problem is putting force, a little bit of force to actually press it onto the pad to make connection. And three is the third problem is the size of the two. They are quite close in size. Almost, well, it's not really the same, but this wire is way too big comparative with the size of this pad. And it's creating that physics, lever. If this is the spot weld, and this is the pad so little, and this is so long. If you move it a little bit, it will practically break it from its enclosure. It will bend it out of the shape, out of place, out of everything. It will take it out pretty much. Either the pad or the welding, spot welding. If the spot welding is not good enough, it will break from the spot weld. That's the good case. But the bad case is if the spot weld is good enough, if you bend this wire too much, it will be able to take out the entire pad, to take it out from its plastic enclosure that is there. It's very, very extremely fragile. Actually, let me draw it for you. This is how is the plastic here and here. Probably a bit more thicker, but it's almost nothing. It's almost nothing here. And here is like this. Is a little bit like a tiny ear, but it's so tiny. And this is the plastic, and this is the pad. And the pad is going inside, something like this, inside the LED. I'm making it with the pad up, pointing up. And here is the wire bonding probably of the LED itself, and this is the negative. So this is the positive pad. That is a little tiny bit. You don't really see it. It's out there, but it's a tiny bit. And this is the plastic that is holding it, and it's almost nothing here. It's almost no plastic. It's like staying in air. It's barely. It's extremely fragile, and it's barely catched in the plastic here. And also here, it's the plastic. It's probably like this. This is the plastic here. It's extremely fragile, very, 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 very fragile. For this thickness of the wire, I was thinking with something even finer than this wire, like 012, 015, my copper enamel copper wire. But those are coppers, and I need steel. This is from steel because it's magnetic, and a copper is not magnetic. You can make very quickly the difference from the two, like that with a magnet. And if it's magnetic, it's steel. If it's not magnetic, it's something else. Most probably it's a copper wire, usually, or aluminum. Who knows? But that's the problem that I'm facing with this model here. And I recently received another one. I actually buy it. It arrived in 1 month. This is my old guy that I'm having. They are not put in power right now. They are unpowered. So compare the ends. Look how this was actually very good, extremely good rod. Copper rod. It's still copper right now, but it's blackened. And I use it a lot. Well, probably 15 years I use this guy here. And it was staying, some days it was staying like 5 hours, 7 hours maybe, on, non-stop, without stopping it. It was just staying on, just staying hot, 5 or 7 hours non-stop. So yeah, it's I'm not sure. This is brand new, and this is not. I'm having a little bit of story here. This is not its original pointer. I don't know how it's called in English. This is original pointer. It's a bit thicker here. These guys, I have them from 2 years ago, probably 1 or 2 years ago. I buy like a set of 3 of them, all the same, 0.2 millimeters. It's the tip of the dimension of the tip. And this one I'm not sure, probably 0.8 or 1 millimeter probably here in the very end. It is having a little bit of solder right now, and it's a bit more thicker than it is, but yeah, these are quite good, very good actually. Let me actually show you and compare. You see, it's also having some solder on the tip, but it's almost the same size as the pad, which is extremely good. This, like I said, I just tested it, and if you have a very, very good pointer of the soldering iron, you can actually get there, and very quickly. You don't stay with the hot pointer on the pad. You lick it like that, of course the solder will be flowing, will be liquid on the tip of the pointer, and that liquidness will stick to the pad a little bit if you do it like that. And yes, it matters how thick the pointer is. But as a reminder, my 7-segment display that I recently built, I built it with this guy. I had actually a small wire of copper here under this guy, under this very thick end, and I did everything with that very small wire, very small, well, smaller. And yeah, it's morning right now. You can see the sun coming from outside and casting some shadows. Hello. And that's how it's looking from my window. Yes, unfortunately, I am very, very disappointed on this project because I really don't see a way of making it work. Shit. But this is good for other projects, for bigger projects. Maybe I'm planning to test it on some batteries to spot weld them. Batteries, I have very small batteries around, and I was planning to spot weld them for quite some time, and they are already consumed, those batteries, and they are consumed a bit. And I have a boosting circuit that is boosting that little bit of voltage that they those small batteries they left with, and I want to use them in my other projects. Yeah, pretty much this is it. Thank you very much. Unfortunately, it didn't work on the LED pads. It was a crazy project. I did try the impossible, and the impossible kicked my ass. But doesn't matter. All right. So in conclusion, it didn't work with spot welding because three major problems: direction of the leg that I want to spot weld, pressure of the leg to stay on the pad and make good contact with the pad in while I'm spot welding it, and the third recent and quite important problem was the thickness and how long it is, and I really need something that is way more thinner comparative with the dimension of the pad. So these three main problems I had so far, and it didn't work with spot welding, but it is possible. I did actually manage to spot weld it a little tiny bit. For a couple of seconds it was spot welded until I tried to take it out from the solder there and it got ripped off from the other side as well. But the conclusion here with this experiment that I did so far is other ways of doing it. And the other way, this is the other way. A very fine tip and good, a new, most probably a new solder iron with a new tip, pointing tip there. And this is an alternative solution to actually deal with the actual physical size of the pads that you have there. And it's extremely fragile, everything that is on that positive pad specifically. The negative pad is a bit more sturdy, is a bit more serious there. It is holded a bit better, but the positive is absolutely, it's a disaster. And this tool that I'm having right now, it's better, way more better than anything that I had so far, and I hope for other SMDs it will do a good job in the future. We will see, probably you will see it more in the future videos from now on. But this is the conclusion. Another mindset, another solution, different from everything I tried. Actually I stayed probably 2 weeks on this project that you are seeing here, most probably 1 or 2 weeks for this transformer spot welding stuff, that I will use it but for completely other projects. But mainly I use it, I build it with the idea in my head to spot weld those small pads. I know it's a crazy idea, and I actually managed to do it for a very little time. But it was a little bit of success, but not really the definitive success, you know, something that I can brag with it. But there are other solutions. This is my other solution that I'm having there, and that's it. This is the conclusion. Thank you very much. Leave a like, motherfucker, and see you on the next project, probably. See you later. Bye-bye.